Good morning, friends. It is Friday, April the 3rd, and we have completed 2 weeks online. So, and this will conclude an entire chapter online. It's 32 degrees here in Alva, Oklahoma, so we have broke out the winter clothes again. It was very sad to do that, but it's freezing here. So I hope you're somewhere warm. Maybe. A couple of housekeeping things. So today's section does finish out our chapter 14. And so to kind of look ahead to next week, and I will next week post another week at a glance. I think that helped. Hopefully that helped. To me, it helped me. It was less announcements for you guys, and you could just look at what the week was. So hopefully that helped for you to kind of know what to expect for the week. So our week next week will consist of Monday. I will open up a quiz for you that will be over section 4 and section 5. It'll be in my math lab, and it will be open from 8 a.m. to midnight, 8 a.m. Monday to midnight on Tuesday. So it'll be open Monday and Tuesday for you. So be sure to hop in there. Give yourself some time. It is a little bit longer just because surface area and volume do take a little more time. So make sure to give yourself time to do that. So that'll be Monday's assignment. And then I'll also post review information for you on that. And then Wednesday, my goal for Wednesday is to host a Zoom meeting with you. So kind of make plans next week. If you could let me know kind of what times work for you. Evening is really best, afternoon or evening. So my goal is to kind of do it like at 8 o'clock. Maybe if you have kids, your kids will maybe be in bed by that time. Or so my goal is 8. So Wednesday to host a review session for the test. That will be on Friday. So your test will come through WebAssign, or will come through my math lab, and we will proceed from there. So my goal is to create a review for you from my math lab, so you can kind of get the hang of what it might look like, and then post that. And then it'll be kind of the same format for your test. So that's kind of my goal as of this point. So just kind of a heads up for what is coming next week. And then the great thing about the way this class is set up is once we get through chapter 14, we go back to chapter 13, and it is all like fun activities. And so there are activities that you can definitely do at home. You can actually do them with your kids if you have kids. And so this will be something, just activities, and so there'll be credit for those activities. So we may have a couple of Zoom meetings there for you to show off your the stuff that you did. So that's kind of the plan there. So let's talk about today. So let's talk about volume and temperature. We're not going to talk about mass. That's covered usually in biology or physical science when you're doing your labs there. So we're going to talk about volume and temperature. So volume is for a three-dimensional figure. So we kind of connected perimeter and I wrote something wrong here. This should not be surface area. We connected perimeter and area. Let me get this right. No, oh my gosh, it's Friday and I haven't got through my entire cup of coffee yet. Okay, in a two-dimensional figure, it was area. We found just the area, not the surface area. So make sure in your notes you don't put surface area. So we found just the area of a two-dimensional figure. Well, what that correlates to in a three-dimensional figure is volume. So how much does it take to fill up that space? So with volume, because we have a three-dimensional figure, kind of the question is, you can kind of think about it as how much stuff can I put inside of the figure? Okay, whether I'm filling it with water, whether I'm filling it with paper, how much stuff can be inside that figure. So three-dimensional figure, we're looking at volume, but it's comparable to the two-dimensional area, not surface area. So make sure you change that in your notes. I'm sorry. Actually, what did I do? I did something the other day. No. Somehow the other day I got some sort of highlighter, but apparently I'm not going to get that today. So, okay. So it's a couple of examples where when we found area, we just had the square. Remember, we used the geoboards, and we just had the square. Now we're looking at three-dimensional as a cube. So 1 unit cube. And then for volume, if you look at this, this is 4 cubic units because there's 4 cubes. But if surface area, you're looking at 18 units because there's 18 sides to this. So again, you want to make sure to label with cubic units, cubed units. So inches cubed, meters cubed, centimeters cubed. Okay, because now we're taking into length, width, and height. Length, width, and height. Okay, so here is your formulas for you that we will use most often. B is the area of the base. Area of the base. So you may have to refer back to section 2 where we found area and take some of those formulas for area of the base. Okay, so then your height for volume, your height is referred to as the height of the figure. How tall is the pyramid? How tall is the cylinder? Not the slant height. So with what we did on, let me clarify real quick before I teach you guys wrong. Okay, because that's the last thing I want to do, and I have my surface area. Okay, so when we did surface area of three-dimensional figures, the height, we used slant height because we wanted the sides. We were measuring the sides. Here we want the height of the figure. So this is not the slant height. Now you may be given the slant height and you have to use the Pythagorean theorem to actually find the height. But there's a couple of examples in there that we'll look at. So R is your radius anytime you're doing anything with a circle. So you can kind of see those formulas. So refer back to those as you need to. So a couple of examples. Now, first of all, over here on the right-hand side underneath my picture, if you notice in this example, it has 5 and then the 2 dash marks. To kind of refresh what that means, the 2 dash marks means inches. The 1 dash mark means feet. Okay, so if you see those markings, then you can see that the 1 and what those 2 mean. Okay, so find the volume of this, basically a rectangular prism. So volume for a rectangular prism is area of the base, capital B, area of the base times the height. So our base is a rectangle. So the area of that base is length times width. So 10 times 3, and then the height is 15. So you have 450 centimeters cubed. Okay, the next one, find the volume of the cube that is 5 inches long. 5 inches long. So it's a cube, so that means all the sides are the same. So that means the length is 5, the width is 5, the height is 5. So if you're talking about a cube, then all your sides are the same. They're all squares. So again, volume is area of the base times the height. So area of the base, because it's a square, is just length times width again, and then times the height. And remember, cubed. The next one is a cylinder, a circular cylinder, because the top and the bottom is a circle. Okay, so here's our formula for that. Again, the height is how tall the right cylinder is. It stands up straight. Now, I did leave this in terms of pi. I noticed in your book on some of the homework, it does leave it in terms of pi. And also in my math lab, some of the answers, it does leave it in terms of pi. So this is what is known as an exact solution. An exact solution. So if you're asked for an exact solution, it's still in terms of pi. If you're asked for an approximation, you can go ahead and multiply 250 times pi. Okay, the next one's a pyramid. Okay, so, and I just see that I misspelled pyramid incorrectly. I'm going strong today, ladies. Okay, just so you know. One moment, please. Okay. So pyramid, if you'll notice the height here, the height is from the top of the pyramid straight down. It does come down perpendicular and form that right angle. So if you were given a slant height of the triangle on the outside, you could find the height by the Pythagorean theorem. But here we have the height we need. Remember, capital B is area of the base. So 4 times 4. And so 1/3 times 4 times 4, and then times 5. So again, if you're looking for an exact solution, it's 80 meters cubed. If the approximation is okay, or for a decimal is okay, then just divide it out. I'm still working with MyMathLab and trying to figure out what answers are acceptable and what aren't. So know that I am going back through some things to look to make sure that it's taking your answers if they are correct. Next one is a cone. Right, and our formula for a cone is 1/3 pi r squared h. So if you'll notice, you're not given the height here, you're given the slant height. So this is an example where you can find the height of the cone by using the Pythagorean theorem. So your hypotenuse is 10. Basically, you're taking a slice out of that cone. So you can set it up into the Pythagorean theorem and you get 8. Okay. So 8 is your height, and then substitute in. Again, I left it in exact value, 96 pi centimeters cubed. But if a decimal is okay, go ahead and create a decimal with it, just by multiplying. Okay, conversions. So again, we've been doing conversions through each type. So when we look at conversions with cubics, where when we did area, we had to write it down twice. Okay, because you had meters squared or inches squared. Here you're having cubic. So that means that you've got to write it down 3 times because it's a cube. And so I gave that example for you here. I'm touching my face, sorry. I gave that example for you here for each one of these. For the first 2, you can use King Henry, but remember in the notes on the bottom, if you're using King Henry, you must multiply your hops, and I just misspelled hops, not hopes, okay? You should also multiply your hops by 3. So with this first one, to go from meters to centimeters, it's 2 hops to the right, but when because it's cubic, I have to multiply by 3, so that means I'm actually taking 6 hops to the right. Okay, same thing with here. To go from millimeters to centimeters is 1 hop to the left, but I have to multiply by 3 because it's cubic, so I'm going 3 to the left. And then with yards and feet, again, we don't have, we can't use King Henry, so we have our feet to yard ratio. Okay, 3 feet to 1 yard. And remember, yards have to be on bottom because you're wanting them to cancel out with this 45 yards cubed here. Okay, so again, we have some conversions, and again, you may need to look back in previous sections to get those conversions. So if you don't know that 3 feet is 1 yard, or if you don't know 10 millimeters is 1 centimeter, you can go back into those conversions. Last thing we can talk about is temperature. Okay, so Celsius and Fahrenheit, so depending on where you live or what you see, sometimes things are in Celsius. My friend spent 2 years in Hungary, and she still gives me the Celsius temperature. But she also lives on military time too, so it's fun when she tells me time and temperature. So fun times. She is back in the States, but it's kind of humorous. So we know that 0 degrees Celsius, 32 degrees Fahrenheit. These are some of the things that we know. But here's the actual conversion. So for every 5 degrees on the Celsius scale, there are 9 degrees on the Fahrenheit scale. So you can create this conversion from Celsius to Fahrenheit, or from Fahrenheit to Celsius, and from Celsius to Fahrenheit. Okay, so convert 70 degrees Fahrenheit to Celsius. So we use Celsius is equal to 5/9 times Fahrenheit minus 32. Substitute in and simplify. Okay, so that finishes up this section. Remember, on Monday, we're going to take a quiz over surface area and volume, so 14.4 and 14.5. So you definitely have the weekend to get caught up on those and kind of try some of those. So, and I hope you have a good weekend, and I will see you on Monday. Be sure to reach out if you have questions.